when the methane is in combustion process, when methane undergoes combustion, what is happening here? CO2 gas and H2O will be formed. CO2 in gaseous form, H2O in liquid form will be formed. For this reaction, what we are asked to calculate, this enthalpy change they ask. Given enthalpies of formation of methane. So enthalpy of formation, how to represent? Delta H formation. Delta H formation means enthalpy of formation of CH4 is given. How much is given? Minus 74.8 kilojoules. So it is what now? Enthalpy of formation of which one? CH4. Enthalpy of formation of CH4 is given to you. First try to listen and see and understand problem. I will send you PDF. Okay. So the enthalpies of formation of CH4 means enthalpy of formation of methane is given minus 74.8 kilojoules. And enthalpy of formation of CO2, how much is given? Minus 393.5
kilojoules per mole.
Minus 393.5 kilojoules per mole is given what now? Enthalpy of formation of which one? CO2. Enthalpy of formation of CO2 means what does it mean here? When CO2 gas is formed, when CO2 gas is formed from carbon element and oxygen element, how much heat energy is absorbed, released here? Minus means released here. 393.5 kilojoules energy is released when CO2 is formed. And when CH4 is formed, when methane is formed from carbon and hydrogen, how much heat energy released here? 74.8 energy is released here. That is the meaning of enthalpy of formation. And enthalpy of formation of water is given here. Minus 286.2 kilojoules per mole. So enthalpy of formation of water, enthalpy of formation of CO2, enthalpy of formation of CH4. 3 given. They asked to calculate total reaction. For the total reaction, enthalpy change they asked here. Okay, there is a ask here. So solution, what is this for this now? Enthalpy of formation of reaction. It is for reaction, for the total reaction. So enthalpy of formation of means enthalpy change of reaction. This not indicates what? Standard. Standard enthalpy change. Standard enthalpy change of reaction is equal to always what now? The enthalpy, standard enthalpy of formation of products minus reactants. So the total enthalpies, the sum of all enthalpies of formation of all the products minus the total enthalpies of formation of all the reactants. So enthalpies of formation of products minus enthalpies of formation of reactants. So this will give the change in enthalpy of the given reaction. Okay, now first products you check it. What are the products in this reaction? CO2 and H2O. How many moles of CO2 available here? 1 mole CO2. How many moles of H2O is available here? 2 moles. So that point is the total enthalpies of products minus the total enthalpies of reactants. Now products, what are these here? Enthalpy of formation of CO2 first. 1 mole is there now. So 1 into enthalpy of formation of CO2 plus here how many moles of water is there? 2 moles. That's why 2 into enthalpy of formation of water. 2 into enthalpy of formation of water. This is total enthalpy of formation of which one? Products minus again reactants. Now reactants, what are these here? Methane, 1 mole of methane is there, 2 moles of oxygen element is there. Here methane is compound and O2 is what? Element. Okay, so now CH4 and O2 are there here. So that is what now here the enthalpy of formation of methane compound plus enthalpy of formation of oxygen element into 2, because oxygen how many there here? 2 there. 2 into O2. 2 into enthalpy of formation of O2. So this enthalpy of formation of element is always 0. Enthalpy of here, what is element in this? O2. Enthalpy of formation. Enthalpy of formation of element, any element, not only O2, any element is equal to what? 0. Enthalpy of formation of any element is 0, whether it is H2 or N2 or O2 or any element will be 0. Remember. So enthalpy of formation of methane plus 2 into 0. Now see, enthalpy of formation of CO2, how much is given? Minus 393.5 given for CO2. Okay, plus here 2 into water, how much is given? Enthalpy of formation of water minus 286.2 given. Minus means products minus reactants. In the reactants, what we have to take? Only methane. We should not take oxygen because it is 0. 0 into 2, 0 here. So enthalpy of formation of CH4, how much here? Minus 74.8. This for methane plus 2 into 0. So like this, we have to take what? Products minus reactants. Now this total value will be minus 891.1 kilojoules. It is what now here? Enthalpy change, standard enthalpy change of reaction, the total reaction. The total standard enthalpy change of reaction. This is equal to what? Products minus reactants. Did you understand this question, ma?
Yes, sir.
So what is the formula for this? Which formula we have to remember for any reaction? Enthalpy change of any reaction is equal to the total enthalpies of formation of the products minus the total enthalpies of formations of reactants. Sometimes, listen, in this problem, they have given enthalpies of formation. Sometimes what they will give you, enthalpies of combustion will be given. Enthalpies of combustion. Enthalpies of combustion when we are given. Now in that case, delta H of reaction. Delta H of reaction. If what is given, enthalpy of combustion is given, suppose. In that case, what we take now, what minus what we have to take? The enthalpies of standard enthalpies of combustion of reactants we take now. What we take? Reactants minus again delta H naught of combination of what? Products. Now in this case, what we are taking? Reactants minus products. Okay, reactants minus products we take. What we take? Reactants minus products. Is the concept clear? So when we take reactants minus product, tell me. So when you are given enthalpies of combustions, then we have to take reactants minus product. But when you are given enthalpies of formation, we have to use products minus reactants. So this difference we have to understand. And in which case we also use this reactants minus products, I told you. In which case, bond energies, bond enthalpy of all reactants, bond enthalpy of all reactants minus bond enthalpy of all products. So in these two cases, in case of combustion values and bond energy values, we have to use which formula? Enthalpy of reaction is equal to reactants minus products we have to take. This point everyone should remember. Is the point clear to all?
Yes, sir.
Anyone tell me in which case we have to use product minus reactant? Enthalpy of product minus reactant.
Formation.
If we are given enthalpy of formation. And when do we use reactants minus products?
Enthalpy of combustion and bond energy.
Combustion values and also bond enthalpy. Bond enthalpy means bond energy values. Bond energy meaning what? The energy required to break the bonds in given molecule. The given molecule, how much energy is required to break the bonds is called bond energy or bond dissociation energy. So bond energy of reactants minus bond energy of products we have to take. So this is one example. So based on this, one more example, you only have to take concept here. See, the standard heats of formation. A heats is nothing but enthalpies. Enthalpies. So the standard means 0, like this, not. So standard heats of formation at given temperature. What is temperature given? How many Kelvin? 298 Kelvin means how many Celsius? 25 degrees Celsius. For CCl4 gas, carbon tetrachloride, and H2O gas means steam. H2O gas, then CO2 gas and HCl gas are given. You are given what now? Formation value is given, combustion given, bond energy given here. Formation is given. Enthalpies of formation given, remember, for every compound. So it is enthalpy of formation of first one what CCl4, and the second one is what H2O, third one is what CO2, and fourth one is HCl. They are given. Calculate delta H naught at this given temperature. Means delta H naught of reaction only. Delta H naught for the reaction at the given temperature. So now it is the reaction given. What is given? CCl4 gas plus 2H2O gas gives rise to CO2 gas plus 2HCl gas given. Once go through the solution given here, ma. The balanced equation now. How many moles of the H2O there? 2 moles there. 1 mole of CCl4, 2 moles of H2O, 1 mole of CO2, and 4 moles of HCl there in the given equation. Now we have to take what now? Enthalpy of reaction. Enthalpy of given reaction is equal to what minus what we have to take now? Products minus reactants. Means your formation is given to you now. That's why enthalpy change of formation minus products minus reactants we have to take. Now see products, what are there here? 1 mole of CO2, 4 moles of HCl. So here 1 into enthalpy of formation of CO2 plus 4 into enthalpy of formation of HCl. Now this is what now total enthalpies of formation of products minus here what is given? Reactants what now? 1 mole of CCl4, 2 moles of H2O. That's why 1 into enthalpy of formation of CCl4 plus 2 into enthalpy of formation of H2. So when we substitute the values, we get what now here? Minus 41.4 kilocal. Minus 41.4 kilocalories given here, remember. Previous question they gave kilojoules, but here it is given kilocalories. Sometimes here calories given, kilocalories given values. We will get final answer in kilocalories, but the options will be in kilojoules. In that case, 1 calorie is equal how many joules we have to write? 1 calorie is equal how many joules?
4.2.
4.2 joules. 4.18 means 4.2 you can take. So 4.2 joules we have to take. So if you are asked in joules, what we have to know? Minus 41.4 minus 41.4 kilo into what now? In place of calorie, what we take? 4.2 joules. So then we get in kilojoules now. So 41.4 into 4.2 kilojoules. So like this, whether option is given in joules or calories, we have to observe it carefully. What is the MKS unit of energy here? Joules. So mostly joules will be there in options. Sometimes calorie will be given and answers will be in joules, remember. So this is about what now here? Calculation of enthalpy change of reaction by giving what? Enthalpies of formation of reactants and products. Is this clear, my concept? Next, one more example. See. The molar heat of formation. Here heat means what? Enthalpy. Molar heat of formation of NH4NO3 means what? Ammonium nitrate solid. Ammonium nitrate solid is given here. One salt is given. Is minus 367.5 kilojoules. Minus 367.5 kilojoules is what now? Enthalpy of formation of ammonium nitrate. And those of N2O. N2O is what now? Laughing gas. N2O is what? Laughing gas. What is laughing gas? Chemical name? Nitrous oxide, nitric oxide it is. It is nitrous oxide, laughing gas. So nitrous oxide gas and H2O liquid are also given here. So nitrous oxide formation, how much is given? Plus or minus given here? Plus. So for nitrous oxide N2O, the enthalpy of formation is how much? Plus 81.46. Means if N2O is formed, energy is absorbed or released here. Enthalpy of formation of N2O is positive. Means what? Enthalpy
Energy is absorbed.
means energy is absorbed here. So this much energy
The
will be
thermic
absorbed
process.
when N2O is formed from nitrogen element and oxygen element. If N2O is formed, it will be plus 81.46 kilojoules. And what is minus 285.78 kilojoules here? Enthalpy of formation of H2O. Enthalpy of formation of H2O is given. Kilojoules given, remember. At given temperature, how much now? 25 degrees Celsius. Sometimes Celsius given, sometimes Kelvin will be given. How much Kelvin here now? 298 Kelvin. And 1 atm pressure. What is the pressure given here? 1 atmospheric pressure is given. So normal temperature is given 1 atm here, and room temperature is given. Room pressure 1 atm. Room temperature 25 degrees Celsius. Now they ask what now? Calculate delta H and delta E for the reaction. Now in the previous two examples, what we have discussed only delta H calculation we studied. Now here what is asked extra? Delta E. Tell me what is delta E here? Delta E is what? Internal energy change. Internal energy change of reaction. Instead of delta E, sometimes what is also used? Delta U will be used, remember. Delta U or delta E, anyone say. It is internal energy change. What do you mean by internal energy? That all types of energy, means all the types of energies in the given molecule together called what? Internal energy. All the forms of energies in a molecule together known as what? Internal energy. Means one molecule may be having rotational energy, one molecule may be having, same molecule may be having thermal energy, kinetic energy, or different forms of energies will be there now. All those forms of energies of a molecule together known as what? Internal energy. So the internal energy change they ask here. Here delta H we can calculate, and by using the enthalpies of formation. After the delta E we have to calculate. Remember. So equation is given to you already. What is given in the question? Ammonium nitrate solid is heated. To convert into what? N2O gas and 2H2O liquid. Okay, it is given equation. So 2 moles of H2O product, 1 mole of N2O product, and 1 mole of NH4NO3 salt. Now see. Now enthalpy change, standard enthalpy change of what? Given reaction. For the total reaction, the standard enthalpy change is equal to what now? The standard enthalpy of formation of products minus standard enthalpy of formation of reactants. So now products, what are the products here? 1 mole of N2O, 2 moles of H2O. That's why enthalpy of formation of N2O less 2 into enthalpy of formation of H2O minus. Now product is what now here? Reactant is what? Only one. One reactant, what is this? NH4NO3 solid. So 1 into enthalpy of formation of ammonium nitrate. Now by substituting all these values here, we get what now? Minus 122.56 kilojoules. It is what now? Delta H. Delta H not of reaction. Delta H not of reaction, we have got it. And now delta H they asked, delta E they asked here. Delta E. So now delta E, how to calculate? Remember. Sorry. Just a moment. No? Yeah, now check it here. So in this now, what is asked here? Now we have what now? Delta H naught of reaction result. Now what we are asked to calculate? Delta E they asked. Now see, relation you have to remember this one. Delta H is equal to delta E plus delta N RT. Delta H is equal to what? Delta E plus delta N R into T. Here delta N is for gases only, remember. Delta N for gases. is equal to what formula here? Products gases minus reactant gases. Number of moles of product gases and what? Number of moles of reactant gases. Tell me now, in products totally how many gases there, how many moles of gases there? 1 mole gas is there here. Here H2O liquid na, but N2O gas. So 1 mole of gas is there in the product side. And here, how many moles of gases in the reactant side? 0. 0 moles of reactant gases. So reactant gas is not there here. Reactants only solid is there, no gas is there. So how to get delta Ng here? Delta Ng for gases is equal to what minus what? Products minus reactants. So how much delta N value here? 1. So how do we calculate this delta N for gases? Tell me. Number of moles of gaseous products, minus what one? Number of moles of gaseous reactants. Number of moles of gaseous products minus number of moles of gaseous reactants will be equal to what? Delta N for gases. Do you remember this one? In chemical equilibrium, we studied this one, delta N for gases. So this delta N we have to substitute here. So delta H is equal to delta E plus delta N RT. See now, from this what we are asked to calculate here? Delta E we are asked to calculate. Tell me now, from this delta E is equal to delta H minus delta nRT. Delta H minus delta nRT. So delta Ng gases, how much you got? 1 you got. And R value how much? 8.314 joules na. But here we have taken kilojoules. Why? These all values are given in kilojoules na. All the enthalpies of formation given in kilojoules. So R value also should be in kilojoule. So R is equal to what generally? 8.314 what? Joules. That is equal to 8.314 into 10 power minus 3 kilojoules. Is that clear now? So this value we have to use it. Kilojoules value we have to use for R. This is kilojoules. Next, T is given how much now? 298 Kelvin. 298 Kelvin, why? This 25 degrees Celsius is equal to 298 Kelvin. So we have taken temperature. Now delta E is equal to delta H value minus delta nRT. By substituting all these values, we get how much here? Minus 125.037 kilojoules. So we have to round off the values. I told you how to round off in some basic concepts of chemistry. So rounding off should be done here. Okay. So like this, we have to minus 125.037 kilojoules. It is delta E. Delta E means what? Internal energy. Internal energy change. So internal energy of what now? The reaction. So which one is greater? Check it once. Delta H value we got minus 122 now. Delta H, how much you got? Minus 122. But delta E, how much you got? Minus 125. Okay. So it is what now here? The reaction of enthalpy of reaction and internal change of reaction. Are you able to understand my concept?
Yes, sir.
Yes,
So then two concepts we discuss now. First thing is what? How to calculate delta H of reaction. Second concept, what now? How to calculate delta E of reaction. Okay. The first reaction, what we have taken examples, enthalpies of formation of products minus reactants we have taken here. Then we got delta H. From delta H, how do we get delta E value? Delta H minus delta nRT. So this calculation part is very important here. If you understand that concept is different here, it will be easy to understand. But application means substitution of these values and the calculation part is very important. There you should not confuse. Okay, ma. Next, one more example, check it. See, the heats of combustion Now, what is given? Combustion given or formation given?
Combustion.
Combustion. So heat of combustion is given. So the standard enthalpy change of combustion. The standard enthalpy change of combustion of methane and C4H10 is what? Butane. Butane. Methane, butane are given here. So methane, how much here? Minus 890.3 kilojoules. And butane is given minus 2878.7 kilojoules per mole. In LPG, what will be there? In liquefied petroleum gas, what will be chief component? Butane, N-butane. So you see how much is there? 2878 is there, combustion value. Okay, means when you combust 1 mole of butane, this much energy will be released, minus 2878.7 kilojoules energy will be released here. It is combustion. Which of the two has greater efficiency? Which of the two gases has what? Greater efficiency as fuel per gram, not per mole, per 1 gram. That means if you burn 1 gram of fuel, how much heat energy will be released from each compound? We have to check it now. Okay. Now first check it here concept. Molar mass, gram molecular weight of methane, how much now? 16. So gram molecular weight of methane is 16. Means 16 grams per mole. 16 grams per 1 mole. 1 mole is equal to 16 grams of methane, remember. So heat produced per 1 gram. Heat produced per 1 gram of methane. So from given value, what we have to understand here, tell me? 16 grams of methane. 16 grams CH4 is giving how much energy, tell me? Minus 890.3 kilojoules. So this much energy is coming from how many grams of methane? 1 mole. 1 mole means 16 grams. Then 1 gram methane will give how much? 1 gram will give how much? So 1 into 890 by 16. So like that, a minus 890.3 by 16 will be equal to what? Minus 55.64 kilojoules. It is per gram, it is. Per gram. 1 gram of methane, when you combust, how much heat energy will be released here? Minus 55.64 kilojoules is released here. Next. Molar mass of butane is how much now? 58 grams per mole. 1 mole of butane is equal to how many grams? 58 grams. Because here 4 into 12. 12 fours are plus 10. So it will be 58. So 58 grams per mole is the gram molecular weight of butane. That means here, what is given in the question? 58 grams butane, C4H10, will produce how much heat energy here? Minus 2000. Minus. Yeah, tell me minus how much is given? 2000. Yeah, so 2878.7 given kilojoules. Then 1 gram we have to calculate. Then 1 gram of butane will produce how much? Okay, tell me here 1 into 2878 by 58. Right? So 2878.7 by 58. It is minus that. Then we got minus 49.63 kilojoules per gram. So 1 gram of butane is giving how much? Only minus 49. But 1 gram of methane is giving what? Minus 55. So which is giving per gram more amount of heat energy?
Methane.
Methane is giving more. We should not confuse here. 1 mole of butane will give more. 1 mole butane is giving very large amount of heat energy. 1 mole of methane is giving less amount of energy. Okay. But per 1 gram, if you calculate, the methane is giving 55 kilojoules and 1 gram of butane is giving 49 kilojoules. That means what now? Methane is giving more amount of heat energy per gram. Thus, methane has greater fuel efficiency than what? Butane. Now see, this methane will be chief component in what? CNG. CNG. CNG means what? Compressed natural gas. Compressed natural gas contains what? Methane. LPG, liquefied petroleum gas, contains what? Butane. Now we have the cars running with what now? CNG and LPG nowadays. We have LPG cars, gas cars, and also CNG cars. Now, which is efficient fuel here? The CNG is efficient fuel because CNG contains methane. 1 gram of methane is giving more amount of what here? Heat energy. That's why CNG car will be more costlier than LPG car. Remember. Did you all understand concept now?
Yes, sir.
So next, one more example. Next period we'll discuss about general organic chemistry. Don't miss the class, okay? Next coming up 15 days. The syllabus is what? General organic chemistry from organic chemistry. And from physical chemistry, what is topic? Thermochemistry. So these all things you should not neglect this time. See, the standard molar heats of formation given. Now enthalpy of formation is given, enthalpy of combustion is given. Enthalpies of formation given here. The standard molar enthalpies of formation of ethane. Ethane formula, tell me anyone? Eth, C2, N, double plus C2H6. And carbon dioxide, what? CO2. And liquid water, H2. So for all these, what is given here? Delta HF is given here. Delta HF means enthalpy of formation is given. So it is for ethane, it is for CO2, and this value is for what? Enthalpies of formation given. Calculate the standard molar heat of combustion of ethane. Now, combustion of ethane reaction is given. For this reaction, what we have to calculate? We have to calculate enthalpy of combustion. Enthalpy of combustion of ethane, that is enthalpy of reaction is given. This is to calculate enthalpy of reaction by the given values of what? Enthalpies of formation. Now see, the required chemical equation for combustion of ethane. Now, did they give you equation in the question? Check it once. Did they give any equation? Means equation in the question?
No, sir.
They have not given. Any equation is not given. Simply they said combustion of ethane. Now, how to write combustion of ethane? Tell me. Combustion of ethane, C2H6. Ethane, na? Combustion means burning in what? Burning in oxygen. Burning in oxygen is combustion reaction. In this combustion reaction, okay. Now, what will be the products always? CO2 gas will be produced, and also H2O liquid will be produced. These two only will be the products. Now tell me how many moles of CO2 will be formed? How many carbon atoms available here? 2 there, na? That's why 2 CO2 will form. The balanced equation, how many CO2 must be formed? 2 CO2 should be formed. First concept. Next, how many hydrogen atoms here? 6. 6 by 2, how much? 3. Then 3 H2O should be formed. 3 H2O should be formed. 2 CO2 should be formed. Now, right side, how many oxygen atoms available? 2 into 2, 4, 3. 3 plus 4, 7. 7 there. 7 means here, you cannot write 7 here. 7 means 7 into 2, 14 will come. So we have to write 7 by 2. 7 by 2 O2 means how many atoms will be there? 7 atoms will be there. Is that clear now? So like this, first you calculate what now, write the equation of this, and then enthalpy change of reaction we have to calculate. Okay. So some more equations, some more questions are there. Time is getting up. 40 minutes will be over now. The same question will continue. Immediately after this, we will discuss what? GOC, General Organic Chemistry. Just 5 minutes give break. Again, join when I send the link. Okay, ma?
Okay, sir.
I will send you again.
Okay, sir.
Yeah, I will send you this PDF also. Okay.
Yes, sir. Thank you.
Yes, sir. Thank you, sir.
Join again. Be ready.
Thank you, sir.
Okay.